Have you ever stopped to think about what's really protecting your private messages, your bank details, pretty much your entire digital life? It's not just some vague concept of encryption. Nope, it's something much smaller, way more specific, a cryptographic key. And we're going to break down exactly what that is right now.
So we all kind of get the basic idea, right? Encryption scrambles a message. Decryption unscrambles it. Seems simple, but what's actually in charge? What's the little piece of magic that tells the system how to do the scrambling and the unscrambling? That's the real puzzle we need to solve.
And the answer? It's the cryptographic key. It's not the message itself, and it's not even the super complicated math behind the scenes. Think of it as the secret ingredient. It's the unique password that flips the switch and tells the whole system exactly how to lock and then unlock your private information.
And look, let's be absolutely clear about this. You could have the most powerful, most brilliant encryption algorithm on the planet, a true digital fortress, but without the key, it's just a pile of code. It's a Formula One engine with no gas. The key is the spark that makes the whole thing go.
Okay, to really nail this down, let's use a super simple analogy that we all understand, a good old-fashioned lock and key.
So picture this. You've written down a secret note, and you've put it inside an unbreakable steel box. The act of slamming that lid shut and hearing that click, that's encryption.
So, what's the encryption algorithm in this picture? Well, all that complex math is the lock itself. It's all the intricate pins and tumblers inside designed to be almost impossible to pick.
But here's the thing. Even the world's greatest lock is just a fancy mechanism sitting there. The key, that's where the power is. It's the one and only thing with the right shape to navigate those tumblers and actually open the box. It's what gives you control. So you see, one without the other is totally useless. A lock with no key can't be opened by the right person. And a key with no lock, it's just a piece of metal. Or, in the digital world, a random string of ones and zeros. Real, actual security only happens when the right key meets the right lock.
All right, so the lock and key thing makes total sense. Now, let's pull back the curtain and see how this principle works in the actual digital process.
Check this out. You start with your normal message. That's called plain text. You combine it with your secret key, and you feed both of them into the encryption algorithm. Out comes the scrambled, unreadable gobbledygook, which we call ciphertext. Then, to turn it back, the person on the other end takes that ciphertext, uses the exact same key, runs it through the decryption algorithm, and poof, the original message is back. The key is the one constant essential piece on both ends. Which, of course, brings up a really good question. Let's say a hacker manages to intercept that scrambled message while it's in transit. Why can't they just, unscramble it themselves?
And the answer is just so beautifully simple. Because if you try to decrypt that message with the wrong key, any key other than the one correct key, the algorithm doesn't give you the original message. It just spits out more random, useless gibberish. It's just noise. Only the one single correct key can reverse the math and reveal the original hello world.
Now, I know this might all seem a little abstract, but the truth is you are using cryptographic keys hundreds, maybe even thousands of times a day without even realizing it.
Just think about it. That secure message you sent on WhatsApp? Keys. That little padlock icon next to the website address in your browser? Keys again. Your Wi-Fi password? For all intents and purposes, that's a key. Even the data sitting on your phone right now is protected by layers of keys. They are absolutely everywhere.
And honestly, that's the sign of truly brilliant technology, isn't it? This incredibly complex dance of keys and algorithms is happening constantly all around us, keeping us safe, but it's completely invisible. Your phone and your computer are managing this whole symphony for you.
Now, a real quick heads up. You've probably heard other terms thrown around, right? Like public key, private key, or symmetric versus asymmetric. Those are hugely important ideas, and they are super fascinating, but we're not going to dive into them today. Right now, we're just building that solid foundation of what a key is in the first place.
So, let's boil it all down. If you walk away from this explainer with just a few core ideas, what should they be?
First, a key is all about control. It's not the lock, it's what turns the lock. Second, secrecy is everything. The entire security of the system comes down to keeping that key a secret. If the key gets out, the lock is worthless. And third, they are central, period. Without keys, modern digital security as we know it simply wouldn't exist. And all of this leads us to one last really big question.
In our example, we showed the sender and the receiver using the exact same key. But is that always how it works? I mean, how do you even share a secret key securely in the first place? And is there a better way? We're going to tackle all of that in our next explainer.